So this is going to be a series of videos where I'm going to show how to determine the absolute configuration of chirality centers in critical thinking question 10 and 11 from class activity 8. So let's start with A right here, and I'm going to focus in on the molecule on the left. Recall from the key that these two are enantiomers of each other, and you can imagine that if you had a mirror running right in between them, that you could see that they would be reflections of each other. And they are non-superimposable mirror images, which you can tell if you build the model. So here I've selected out just question A, and as I said, I'm going to focus in on just doing the left one here. So now you can see on the right here, I have built a model of this molecule. You can see the CH3 groups are in the back there. You can see that the chlorines line up with the chlorines in the drawing. And finally, you can see that the hydrogens also line up. Okay, so the first thing let's do is let's find the two chirality centers. There's one here, we'll call that center A, and one here, and we'll call that center B. And just to continue, we'll also do this on the drawing. There's A, and there's B. So we're initially going to focus in on determining the absolute configuration of chiral center A. Okay, so now what we need to do is we need to rank the groups that are attached to chiral center A. And it's relatively easy to see that the lowest priority, or 4, is going to be this hydrogen, and the highest priority, or 1, is going to be the chlorine. Then we have to decide, we have a carbon on this side, and we've also got a carbon here, so that's a tie. So what you have to do is you have to look at what is bonded to each of those carbons and look for the first point of difference. Okay, so we'll start with this carbon. We can see that that carbon is bonded to, and you go from highest priority to lowest priority, it's bonded to a chlorine, another carbon atom, and a hydrogen. Now we can look at this carbon and we can see that it's bonded to 3 hydrogen atoms. So the first point of difference, chlorine beats hydrogen, therefore this group is going to be ranked 2, and this group will be ranked 3. Put the circles around them so you can see them most easily. Okay, so let's go over here, and while we've got the model here, we can show how things are ranked. We've got 1, we've got 4, we've got 3 back here pointed away from you, and we've got 2 down here. Now, what you can see is that the lowest priority group is coming out at you, so what you want to do is rotate that group away from you so that you can assign the direction that the groups are going. Okay, so now at the top you can see the same image that was on the previous slide, and what I've done here is going from here to here. I've just rotated the molecule around so that this group right here, H, that is the lowest priority group, is pointed away from me. And now I can see this is still group 1, this is still group 2, although I should use a different color so you can see it, group 2. And up here we have group 3, and as I said, I'm holding group 4, which is the hydrogen, in my hand. If I now trace around, I can see that this is going clockwise, therefore this chirality center is R. Chirality center A is R. Okay, so now we can focus on chirality center B. Once again, the chlorine is going to be the highest priority, and the hydrogen is going to be the lowest priority. And exactly the same thing for the other 2 groups. We've got a carbon here, we've got a carbon here. The carbon on the top we can see is bonded to chlorine, carbon and hydrogen, and this carbon we can see is bonded to 3 hydrogens. Therefore, chlorine beats hydrogen. Therefore, this is going to be priority 2, and this carbon here is going to be priority 3. All right. All right. So this time I'm not going to rotate the model around when I determine the absolute configuration of chirality center B. What am I going to do? I'm going to say, all right, here we're going from 1 to 2 to 3, okay? And same thing here, 1 to 2 to 3. Okay, so this looks like it's going around counterclockwise, which it is. But remember that in this model, we have the lowest priority group pointing out towards us. And we know to assign the chirality centers, we need to have it pointing away from us. Therefore, if the lowest priority group is pointing towards us, when I draw this circle and try to figure out if it's going clockwise or going counterclockwise, that means it's going the opposite of what it would be if this group was pointing away from us. So that means I just have to reverse it. Therefore, chirality center B is R. So that means the molecule on the left is R, R, and since the molecule on the right is the mirror image, it is S, S, but you should build yourself a model and compare the two so that you can see it for yourself.